Welcome to our November meeting of the Smpte New England section. I'm Marty Feldman, section chair. It's good to see all of you. I think looks like we brought out all of the broadcasters in town. Tonight we have a very interesting meeting. We're going to be talking about the Repack, which I guess has been a boon for some and maybe not so much for others, and has created a big stir throughout the country. We have some wonderful guests from American Tower. Neil Searls and Jim Stenberg will be doing a presentation tonight. First of all, I want to thank Dave Beauvais from WCDB for both hosting and managing this meeting. Thank you very much, Dave.
Just for you like that?
Well, you know.
That's an actual blow.
We're coming off some other meetings that were also very well attended. Of course, we kicked off the year with the retirement party for Mike, and I think Mike's here. There he, yep. And then last month we had an interesting meeting over at Rule on the digital imaging technicians and what that is all about. And personally, I found that very interesting because I'm kind of in that side of the business. I honestly don't know that much about the RF and the tower side, so I'm looking forward to hearing about this. Should be very, very interesting. I want to plug our next meeting, which is December 6th, and that's going to be up in Woburn. It's about over-the-top broadcasting of sports. It happens to be lacrosse, and the manager of that meeting is someone who is involved in building the facility over there, Brad Reed, and I'd like to have him say a few words about what's coming up. Brad?
Thank you, Marty. We're having our meeting on December 6th at Lacrosse. It's basically Lacrosse Sports Network, or MLL, Major League Lacrosse. They're at 2 Presidential Way in Woburn, Suite 2, and it's a new facility. They were located in the area behind WGBH until March of this year, and then they've moved to a new facility, which is quite nice in Woburn. I think Brian Rains, who designed it, will be there to give a brief overview of what went into the design thinking. It's different from typical broadcasting because there's no air path or no cable path. It's strictly subscription over-the-top networking. So he can go over some of the challenges with doing that type of server-based system. And then we'll have a tour and explanation of the operation by Rob Wallace, who's the CEO of the network, and he promises to give us a pretty good rundown of what things have gone on, how they've worked out, what problems they've had, if any, and how it's so that's basically a brief overview of what's coming up in December. So you're all welcome. Thank you.
Thanks, Brad, for putting that together. We have a special guest all the way from New York. Jeff Cohen is the section chair of the New York section, and I'd like to have him come up and say a few words. Jeff?
Thank you, Marty and David and the other members of the Board of Managers here in New England section. Whenever I'm traveling and there's a section meeting that's available to visit, I like to do that. And I'm actually here for the first time at a New England section meeting. So very happy that you guys are hosting, and appreciate your having me here. Just in the spirit of cross-pollination, know that you're always welcome at our meetings and our events. Feel free to stop in. Our next section meeting in New York is November 29th. It will be at Able Cine, and the topic will be large format sensors and new cameras. And then we have our annual holiday party, December 13th. That will be posted on the website shortly, but we've become sort of famous for that event, and you're all welcome to join us. So I'll be sitting here. If anybody wants to say hello after the meeting, please do. And thank you for having me. Thank you, Marty.
Thank you, Jeff. And as I do at every meeting, if you're not a Smpte member, we'd love to have you. There's a lot of benefits. You get the Smpte Motion Imaging Journal. You have access to some of the wonderful webinars and educational programs that are available on the Smpte website, and that is growing greatly. So we hope you'll take part and become one of us and maybe do a little work, because we certainly could use that. So before we get on with the rest of the program, I want to bring up Dave Bouvet. He's the Assistant Director of Engineering here at the station, and he will introduce our guest for tonight. Dave?
First of all, once again, on behalf of Smpte, New England, and WCVB, I'd like to welcome all of you to Channel 5, and thank you for coming. And it's great to see a number of our fellow Boston market stations here this evening, all of whom, are very interested in the topic at hand. A couple of housekeeping announcements. We're always looking to encourage student chapters in Smpte, New England. We'd like to foster the next generation of student membership. So if you are connected with a college, if you are connected with an academic program of any kind, please help us champion the Smpte cause and help us to develop the next generation of talent for our industry. So, and another bit of housekeeping, after tonight's meeting, we'd like to get together all of the WLVI alumni who are in the room for a group photo. As you may know, the WLVI will soon stop radiating, so we'd like to take a group shot. So, and then finally to the topic at hand. For the last couple of years, the broadcasters who share facilities in the Boston market and others have been working with American Tower, the majority landlord for tall tower properties in Boston, on the coordination and development of a plan to answer the government requirement for frequency repacking. It's been quite a process, but I'll make a couple of observations. The first is that it's been said, and I've said it myself, that Boston is a big market, but it's also a small town. And one of the hallmarks of the Boston television market is the amount of the level of cooperation between stations, the tower company, and so the process, while it's been challenging, has also been rewarding because we've learned a lot. We've developed, I think, a great deal of familiarity and ease in discussion. So really hats off to everybody who's involved for your participation, to American Tower for the process that you've put together. And with that, I'd like to introduce two of the principal architects of the process. Neil Searls is the Director of Business Development.
Yes.
I'm going from memory here.
Yes.
So he is, yes, the Director of Business Development for American Tower, and he has really done a great job of focusing the energy of all the broadcasters and their various interests toward a common project. Of course, you need somebody behind all of that who is wicked smart to put together the RF plan. That's Jim Stenberg, former employee of Dielectric, who's now crafting a wonderful antenna, a coordinated antenna package that should serve the Boston area for decades to come. So with that, I'd like to welcome Neil and Jim, and off we go. An evening on the Repack.
So good evening, everyone. Dave, thank you for inviting Jim and I here. We really appreciate it. Marty, thank you for coordinating this event. Smpte New England, really appreciate you guys taking the time to go through this. You know, kind of off of David's comments, it has been a pretty challenging process. And, you know, our title is Adventure, and it has been an adventure. And we're going to share a lot of fairly detailed information with you guys tonight. And we're doing that because the Boston market is so collaborative. The broadcasters we've been working with, both TV and FM, have been really, really good to work with. So Jim is going to get into, and he is wicked smart, he is going to get into a lot of detail. What I would suggest you guys do is feel free to ask any and all questions. We'll try and answer them. We'll also give you guys a copy of this presentation. I'll give it to Dave, and then he can distribute it accordingly. So we've got a fair amount of content to go through. So it really depends on the level of questions, on how fast we'll go through this. But I thought I'd take just a few minutes and introduce you a little bit to American Tower. You know that we're based here in Boston, and I'll get into that in a little bit of detail. And then a little bit about the Repack on a global basis or a national basis. And then some of the accomplishments we've tried to put in place in preparation for the Repack. So there's a lot of activity that's gone on to try and be prepared for our broadcast customers. And then Jim's going to really start talking about the broadband antenna systems that we have across the country, some of the trade-offs in the design, and then actually talk about Boston specifically. So you'll see actually what's going to happen in the market on our towers. And there's a few other things that will likely happen, because once again, it is an adventure, and everyone has to be nimble in the marketplace because things change pretty quickly. But if you guys look at the fcc.com site, you'll see, or fcc.info site, you'll see a lot of the changes that have gone on, because most of those are now public in the market. So American Tower. So American Tower is based here in Boston. Our headquarters is down at Huntington Ave. Our U.S. headquarters is up in Woburn, actually right next to where your meeting's going to be in December. We're at 10 Presidential Way. We basically have been in business for about 20 years. Revenues roughly little under 5.8 billion last year, on target to hit 6.5 billion in 2017. 18 consecutive quarters of double-digit revenue growth, which is a pretty good record. Celtics are catching up to us, so 13 in a row so far. So we'll see how they do Thursday night. That's a big one. We have our core business is really wireless infrastructure. So our biggest customers in the U.S. are AT&T and Verizon. But many of you may not know, we started off as a broadcaster. So 20 years ago, we were a broadcast company. And what we did, we sold our broadcasting assets and kept our towers. And that's how we started. So we've effectively got roughly 40,000 towers in the U.S. We just bought we have about 150,000 towers worldwide. And we just bought another 20,000 towers in India. So you'll see a little bit more of that. But you can see that we're in a lot of different areas: rooftops, distributed antenna systems, etc. So we've expanded, but our core product is really wireless infrastructure, and it's shared wireless infrastructure. So we're highly dependent on our customers to work with us in that regard. So if you look at our global presence, I actually started the American Tower South Africa business, or one of the guys that started that, down in the tip of Africa there for a few years. Then I went up to Ghana, which is next to Nigeria in West Africa, so it's a smaller country next to the bigger country, which is Nigeria. And I was there for 3 years. So after 5 years, I raised my hand and I came back to the U.S., and I'm now working with you guys and on the Repack, and it's been pretty interesting. So specifically on the broadcast side, we are the largest independent broadcast tower company, well over 400 broadcast or tall towers. In Boston, we have a really unique position that we have three really big, good towers, and I'm sure you guys are very familiar with them here. We are pretty much national. So one of the great things from a Repack standpoint is that we have redundancy in most markets. So in a DMA like Dallas, we actually have 5 broadcast towers. Or in Tampa, we have 2. So having that redundancy gives our customers the option to have physical diversity, which is really good. So you have a main system on one side and an auxiliary on the other. So that's really been very, very helpful. And that was most recently we purchased Richland Tower assets, and so that really bolstered our portfolio of towers. And I don't know if any of you guys know Pete Stark, but he's been in the broadcast business for over 20 years. He started selling on the tower side, and now he's on our team. He's been on our team for 20 plus years, but comes with a lot of experience, and he heads up our broadcast team at American Tower. So let's talk about Repack. So Repack, so 987 Class A or full power stations have been repacked. 222 of those are on American Tower towers. That represents 133 American Tower towers. So as a company, we're pretty busy right now supporting our customers and trying to figure out what each of our customers want to do and how can we do it without disrupting any over-the-air service. And then if you kind of peel it back a little further, there's 52 auction winners on our sites. A lot of those are in LA. LA was an incredibly active market as far as auction winners were concerned. There's 8 customers of ours that are going from U to V, so UHF to VHF, and 44 are going off air, and most of which are doing channel sharing, and we're working with those customers as well. So another way to kind of look at the 222 sites is you guys probably know that there's 10 phases. And so we're 4 months into the 36-month repack period. And that sense of urgency that things need to get done need to start to, I think, people need to start to realize that there is a limited amount of time in this project, I think. So if you look at it, you can see that we have 15 projects in phase 1. So phase 1 is basically 8 or 9 months away. Then you've got phase 2, and you'll see the dates at the bottom of those phases. So we have 43 customers in phase 2. And it goes all the way down to phase 10. So we're pretty busy from phase 1 to phase 4. You can see there's quite a bit of activity. And the great thing about Boston, to make it really simple, is there's 2 phases in Boston. So that just adds to the level of complexity, because we have people on certain towers that are in phase 4 and phase 8. So how do you build a plan to manage that phase 4, phase 8 transition? And it's been pretty complicated. Obviously, Jim has been really, really instrumental in designing this, but the broadcasters have been too. So everyone we've been working with, whether it's CVB, whether it's CBS, whether it's GBH, FXT, all been really, really great to work with, and very collaborative and very innovative, and also willing to accommodate for others, which is really unique. So unlike my days when I worked with the AT&Ts and the Verizons and the T-Mobiles, you can get broadcasters in a room and everyone can walk out of there and you still have, you're not beat up. When you're with the wireless guys, it's a little different environment. So it's a good thing, I think, in this industry. So accomplishments. So we started about 2 years ago, and our president made it very, very clear that we needed to provide a very, very high level of customer sat. So effectively what we did was we mapped all of our towers that we thought would be repacked. So we mapped about 100 or so, 110. And it ends up being about 133. So over the course of the last 3 or 4 months, we've been mapping some additional towers. We're also getting all of our leases and all of our site details put together. We're looking to see who has the DNA on that tower. Who's the who's the engineering firm that has the DNA, really understands that tower, making sure we have good relations, we know who that is. We did baseline structurals for all of our sites. So we basically said as is, and then this is what we think is going to happen, and we ran structurals because we could use that as an estimate with the 399s, and we did that. And then we developed scopes of work for each of our various projects. So come July 12th, we were prepared. So we were able to actually get out 173 399 forms. So these 399 forms are very, very detailed documents that provide an estimate of what the project costs are going to be. And we've gotten extremely positive feedback from the FCC and our customers on this process, because we didn't just throw a dart against the wall or the board or whatever analogy you want to use. We actually used a methodology behind it and put a lot of time and work into doing that. And so we gained quite a bit of credibility with the FCC. We also put a fairly significant team and structure in place. We spent a bunch of money with one of the RF vendors. We bought about 10 antenna systems and about 4 miles of transmission line. So we spent about $3.8 million in getting equipment in hand now, ready, so that we don't not meet the transition dates. We continue to work with the engineering teams. We're working on securing crews as we speak. And we've been doing these BBA, which is really the acronym for broadband antenna system design. And that's really the core of what Jim's going to talk about tonight, is the broadband antenna systems that we're looking at doing. So where are we today? So all the initial replication CPs are in and done. The FCC or 399 forms have been submitted, reviewed, and either approved or revised by the FCC in most cases. They've released about $1 billion of the $1.75 billion of funds. So if you are working on Repack projects today, you can spend money today. And that's something that I'm not sure everyone really understands. The sooner you spend it, the sooner you get invoiced for it, they can't take it away from you. The longer you wait, the smaller that pool becomes. So the maximization window closed last Thursday. So that was trying, obviously their power, some of the power for the Repack stations were reduced. They were actually able to maximize that power. So that's an ongoing process for approval and getting CPs. So if you look up the number of stations, you'll see the various stages that they're in. But we've been working really closely with our broadcast customers to understand what their maximization plans are, because as we build these systems, we have to build them with sufficient capacity. If there's not sufficient capacity, we don't want to burn up transmission line or antennas. And we know 3.0 is coming, so we have to design it for some level of vertical polarization as well. So there's one more window. So if you're not repacked, there is a maximization window November 27th. So it's a short window, but you can file in that window. And then finally, we're in month 4 of 36 months. So in the case of Boston, we have basically 18 months to get phase 4 going. And we're in pretty good shape right now. And you'll see by the level of detail that Jim's going to get into that we've put a lot of time and effort, but we're also open to questions, comments, suggestions, because that's the only way you can improve the process, is really to get other people's vantage point as well. So with that, I'm going to have Mr. Stenberg come up, Professor Jim, talk a little bit more about the actual design parameters for these systems.
Thank you. So good evening. Thanks to Dave and group for inviting us. So I've probably got too much information, so we'll try to go through some of this fairly quickly. But so American Tower is been in the broadband antenna business for quite a while at this point, which some people know about, particularly the people in this room know about, but other people don't. The company currently owns 64 broadband antenna systems, including FM as well, and they're about split between TV and FM. So 30 TV antennas, and so my colleague pointed out he was in the wireless industry and he came into broadcast. So in the wireless industry, everything has to have an acronym. So we got this BBA moniker as our new acronym. So that's all we talk about now is broadband antennas. So when he first came in, I was using the words master antenna, combined antenna, and he was like, well, we have to call it something, you know, what's it supposed to be? What's the acronym? So that's when we came up with this PBA. So now I'm forbidden to say master antenna. Anyhow, the important things that we're going to talk a little bit about are what are the limitations. So, you know, engineering is all about making trade-offs, right? So you could design something to handle the most power or have the highest ERP, but everything's got limitations. Ultimately, you got to fit it on a tower and not have the tower fall over. So we'll talk a little about that. So why are we in this discussion about master antennas? Obviously, I just said we have a whole bunch out there now, but we decided 2 years ago, or even earlier than that, that the way we wanted to approach Repack, which we felt would be optimum for our customers, primarily because we had now gotten a whole set of towers from Richland that gave us this second location. Well, let's try to get as much of this resource pooling as we can do and optimize these changes. So that's exactly why we set out with this program. Really, our goal is and was then is to minimize the disruption on air, because you know this is an incredibly inherently disruptive process. You know, everybody's on one channel now, and on some FCC mandated date, we're now on a new channel. That's never happened before. During the digital transition, we had a second channel. You know, we could be on NTSC channel and then slowly phase over onto our new digital channel. Not in the Repack. In the Repack, on June 22nd, 2019, you better be off your old channel and onto your new channel. And I don't know if, you know, a bunch of you were involved in the digital transition, but now it's that night is the night you got to be on and the night you got to be off the other channel. And I actually have no idea how that's going to happen on 150 stations in one night, but that's another story. We do know in some markets how it's going to happen, and that's what we're going to talk about tonight. So that was our thing: minimize the disruptions, and then try to stay within the timeline, obviously, and then future-proof the systems. So one of the ways that actually the antenna technology has changed, and we wanted to adopt this new antenna technology in preparation for the ATSC 3.0 standard, which really ATSC 3.0, one of its primary benefits is to deliver high quality signal to a mobile device. So it allows, at the same time that you have a extremely high quality 4K fixed signal, you can have a lower quality, still high quality mobile signal. So in order to do that, you need to deliver some vertical polarization component of your signal to those mobile devices. So that's what we looked at early on, basically for the last 10 years, pretty much all of the broadcast television antennas have had some vertical component. So what's happened now with the new antenna technology is they've developed a feed system within the antenna that allows you to dynamically adjust this polarization. And that's what this slide talks about. On the left, you see the cross dipoles that make up the element in the antenna. So we're talking about a panel antenna that has these 45-degree cross dipoles. And on the right is this chart that shows you if you feed a phase difference across these two dipole inputs, you can actually change how much vertical component there is and how much horizontal component. So it's a really kind of a revolutionary, although it's not a fantastic new technology, it's a revolutionary implementation of the technology that's been available with these antennas. And we'll talk about more how we do that, but basically by putting a phase difference across the two inputs, you can actually select how much polarization you have. And this shows you an implementation of this dynamic polarization and how you can implement that on the ground. And with a combining system, you can actually change the polarization ratio on each channel. So I didn't bring a pointer, but if you look at the box there where it says combiner, there's two channels in that combiner. And there are two identical chains, which consist of a transmission line up the tower and then the antenna feed system. Those two are locked in phase. So their phase is adjusted during the installation. The phase is set to be 0, 0, right from the input of the combiners all the way up and including the antenna. So the takeaway from this is that a station can run horizontal only right now, so they could run 100% horizontal at their full ERP. So they'd have a transmitter, let's say it's a 30 kilowatt transmitter to run a megawatt. That's a typical kind of ratio, right? And at some later date, they decide that mobile has become a relatively important thing to them, and they want to run 25% of their ERP wants to be vertical component. So they want 250 kilowatts of vertical. So they can come along and add that 7.5 kilowatt transmitter onto the 30 they already have and adjust the phase of the combiner and go up to the 1,000 horizontal and 250 vertical. So it really gives you that upgrade path. And that's been our thinking all along, that that's a great way for stations to independently pick what they're going to do. So some of the things that I have to think about and have been doing most of my career, but particularly the last 2 years, is these trade-offs for a design. Every design has its trade-offs. The primary trade-off is the elevation gain of the antenna. How tall is the antenna versus how much transmitter power does it take to cover the area. So here you can see we have 12 bays, 14 bays, and 16 bays. Those are sort of typical numbers for a TV antenna, and you can see the radiation pattern. The more bays you have, the narrower the elevation pattern gets. You can reach a sort of a critical point where the antenna beam width becomes so narrow that you're essentially shooting over a good part of your audience. So all of this is a trade-offs that you enter in. And you can see I tried to put the, what happens to the transmitter power output, that's the TPO, right? With that gain. It starts at first with a 12 bay, you need 45 kilowatts. And then if you go to 14 bays, you can get a 39 kilowatt transmitter. But look at the trade-off. So this WA, that's the wind area in square feet of the antenna. So you can't get something for nothing. As you go up in the number of bays, the antenna gets bigger, taller, more likely to blow over in the wind, so it's got more wind area, and that's one of the primary trade-offs. So the other thing we do wasn't as difficult in this market because many of the stations, and particularly the ones we have on our towers, are omnidirectional. But in other markets, this is actually in Atlanta that we had to do a study. And what we do is determine who might come into the antenna with us and start to look at what their patterns look like, and then start to put those patterns together into some common pattern. And on the left here is what we've derived as this would be the absolute best to fit all the stations into one antenna. If we could get that antenna pattern, that would be the optimal for the group of stations we had. Well, obviously it's difficult to get exactly that pattern and still make a broadband antenna. So we asked the manufacturers to design to these curves, and then they supply us with the, you can see the small inset there. That was the pattern they supplied, and then we see how it fits into the coverage. In this case, the dashed black line happens to be the FCC replication, and then the blue and the red are two different ERP levels for our antenna. So you can see we did a pretty good job of matching what the station needed for coverage area versus what we could get from an actual antenna. So I should point out this has been no small feat, actually. The FCC really didn't comprehend, in my opinion, how difficult it was going to be to take these stations on a given channel, a high channel, and move them to a low channel. There's some physics that you can't exactly replicate. And they only gave you the ability to go lose 5% maximum. So you had to cover at least 95%, and you could only increase your area 1%. So that's a 6% range that the new pattern had to fit within the old pattern. That is no small feat. Now, having said that, many of the stations have since been able to maximize, and we've been sort of waiting for this maximization to happen, because that's where they really determine what they can really do. But they are only getting reimbursed for the replication. So they had to be within that 6% window, which is really not much of a window at all. And then that's all they got reimbursed is what equipment it took to reproduce that on the new channel, from transmission line antenna. Those were the RF items, and the transmitter, obviously. But the transmitter only for the polarization they might be running now. So if you didn't have a circularly or elliptically polarized antenna before, you're not getting a transmitter reimbursement for that larger transmitter. So that's also been a constant sort of battle to figure out where that lies. Yeah, sure. Let's take this example here on the right. Let me think about maximization in general is taking the FCC coverage area and increasing it until you run into interference problems outside of your existing coverage area. So up to the current maximum ERP, which is a megawatt on UHF. So let's say you were issued during the replication process, you were at a megawatt on channel 45, you went to channel 22 and you were issued a replication ERP of 500 kilowatts, but maybe 600 kilowatts. What you want to do now is on the new channel say, well, I really want to go back to a megawatt. But now so that would be the maximization. You can only do that until such a point as you have interference from other stations. There's a program the FCC has called TV Study that you run to figure out what those levels are. So that's the maximization process. Does that make sense? Yeah. So the second or third, this is the third trade-off, is what are we going to feed this antenna with for a transmission line? Obviously, and from this you can see, the bigger the diameter of the transmission line, the lower the insertion loss. The more power makes it all the way to the antenna. So I can either have a smaller transmitter or more ERP. The problem is transmission line is typically the largest component of load on a tower. So a lot of people think that antenna is the most important load factor, but really the transmission line runs the whole length of the tower. And if you go, an inch or two larger on that transmission line, that can have a huge effect on the loading of the tower. Where you are load percent wise. So that's something you trade off. On the loading side, you'd like to keep it as small as possible. On the transmission side, you'd like to get it as large as possible. Oh, and by the way, it's copper, which is $3.50 a pound. So it costs a little bit of money to make it bigger. So here you see, just the change from 6-inch to 8-inch goes from 59 kilowatts to 53 kilowatts. So all you've done is throw a lot more heat out to the environment by picking the smaller line. So it takes more transmitter power to do the same thing. And then, of course, when we're designing multi-channel systems, we had to worry about how many, the total capacity, and we'll show you some of those charts. But, basically, you can only fit so much into one of these transmission lines. Okay, the last trade-off that I have here is relating to combiners, and there's really kind of two competing technologies. The one on the left is what's called a manifold combiner, and what's on the right is constant impedance. And constant impedance is the most typical combiner that people have seen. Constant impedance is basically the only type used in FM work, primarily anyways. The real differences between the two relate to the expandability. The manifold is a one-shot deal. You design it for the channels you have, you build it. It's relatively, quote, inexpensive, and you operate with it. It's pretty rugged. It's also not particularly large for what it has to do. The constant impedance, on the other hand, you design a module and you build the port, the broadband port of it, so that you can add more modules as time comes along, or there's, God forbid, another FCC auction and repacking, which, by the way, I'm sure there will be, but then we can take those modules and move them around and put other ones in. The other real benefit of the constant impedance, which is becoming more important now, is that you can design these modules for adjacent channels. So now that everybody's been repacked, we used to have all kinds of channels between each other. Now we're all repacked. So everybody's has adjacencies that we have to worry about. So with the constant impedance approach, we can actually combine adjacent channels. With the manifold, we can't combine adjacents, and that's primarily the limitation that we have to worry about, who's adjacent in a given market. Okay, so those are all the kind of things that go into the pot to stir and come out with a solution. And so now I'll show you what our thinking has been and is on Boston. We all know where we are. We happen to be just about in the center of that map. So this is the 3 towers that we have, all within a mile or two of here. And 10 of the 13 stations are on these 3 towers. And that shows them. I'll show them again. But so this is the tops of those 3 towers. On the left is the and Neil also came along and said, I don't understand these names. They all have some street, and you guys call them BZ, and all these different names. We gotta stop that. So we gave them new names. Yes. As they officially are, yes. Not as necessarily others in the room might know them as. But so Needham Heights is our tower that's over on Cedar Street, just down the street here, that WBZ formerly owned. And so that has 2 of the existing broadband antennas on it. So this was a joint project with CVB, GBH, and WBZ, CBS. Back in '99, they started this inquiry into making a joint effort on a new building, new tower or upgrade, and put up these 2 antennas. So those have been in operation now for quite a few years, so we're going to rework the top of that. The other tower is the candelabra on the other side of the highway. We're also going to be changing that, and we're going to talk a little more about that. And then our tower over just to the northeast of here is our Chestnut Street Tower, where we have primarily an FM operation over there, but two full power TVs and a couple of Class A's and low power. So we're also doing a fair amount of work there. So there's plenty to do here, I guess, is the takeaway from this slide. So early on, we kind of realized we needed a scorecard for every market. So we developed this sort of scorecard sketch and just really tried to keep straight who's going where. And so this is the scorecard of how the repack affected our Boston market. We don't necessarily have all the stations in the market, but it's pretty much all the ones that were on our tower. So if you look, the blue with the line, that means that station was a winner in the auction. It will now be going off air, at least with its own 6 megahertz channel. It probably become sharees rather. And the black stations with black call letters, those are not changed, so they didn't have a change in the auction, in the repack. And then blue, again, blue is winners, and green are the repacks. So, and you see the channels they were on for WBZ, channel 20, now moving to 33. So that really gives you the whole deal here for the market. What Neil referred to before was we have phase 4 stations and we have phase 8 stations, and some of them are on the same tower. In fact, some of them are on the same antenna right now. So that's a whole another complexity that we hadn't really thought about that happening, and then it did. So, for instance, in the antenna, the Needham Heights Tower, we have WGBX and WSBK in phase 8, and WBZ and WCVB in phase 4. So how do you keep 2 on while you flip the other 2? That added a whole another layer of complexity, which I think we've solved. And so what we decided to do is put up, the first thing we decided to do is to put up a side mount on the Cedar Street Tower, Needham Heights Tower, and that one can be used as an auxiliary now, and as soon as we need it, we can put WFXT over into that antenna, and they can operate off of that antenna. So that's the starting gun. We put that antenna up. So this is the antenna, but I think I'm going to jump. Pictures worth 1,000 words. This is the antenna that we've now installed on the Needham Heights Tower. You can see it's white there with the red arrow. It's far enough below the tower top so that we can do work on the tower top without having to take it off the air. And it's high enough so it'll still have very good coverage. And it's large enough so that we can put full power operation for 1 or up to 3 stations at full power into that auxiliary antenna. I shouldn't use the word auxiliary, side-mounted antenna. It's a side-mounted antenna. It will be an interim main antenna. So that antenna's up and operating, or ready to be operated. It is not being operated now, but it's, yeah.
What kind of shadow do you get from a side-mounted antenna with respect to the people in back of the tower?
Yeah, that's a good question. I did not put the pattern in here, but that's something we thought long and hard about, and I personally haven't a feeling that people have put up these side mount antennas with an omni pattern. When you put an omni antenna side mounted on a tower, you do not have an omni antenna. So in my opinion, you need to lower the radiation going back into the tower, because it doesn't affect the pattern going behind the tower. What it affects, that reflection affects the radiation going out forward in the pattern. So if you don't reduce the back lobe going into the tower, it hurts you in front of the pattern. And that's something people don't really think about. So it's not the fact that you're not going to get coverage behind, because you probably won't get coverage behind anyways, but that radiation will hurt your forward signal. So all the side mount antennas we're building have reduced back lobe. So obviously, having said that, that is a trade-off, right? So so you have to carefully position the antenna to keep your primary coverage area, and not reduce completely the back lobe, but sort of halfway in between on the back lobe. Is that what you meant?
Yeah, that sounds like an answer.
Yeah. What's that? Yeah, and so you can go through a fairly lengthy and expensive optimization. I have always questioned those optimizations because you really have to have the exact geometry. But in general, you put it out, far enough out, 2 to 3 feet, so that there's some reduction. If you get further out, then you're really going to have mechanical problems. But reducing that back lobe is more important than moving it. The other thing is we're doing broadband antennas, so you can't optimize it on all channels. So when you do that optimization, it really becomes tuned to a particular channel. So this gives you an idea what it was, the 43-foot antenna. The reason we wanted to have this antenna in place is really down the bottom here. So WFXT, their interim main, they will operate this interim main on channel 31, their existing channel, until phase 4. So they have to stay on channel 31 until phase 4. Well, you're about to find out why they can't stay on where they are until phase 4. So we needed a place to put them. And that's why we put this antenna up. And they also have a directional pattern. So we needed to fit this into their existing pattern. Another primary driver for the selection of the pattern was to replicate WFXT. And then it will continue to be their auxiliary after phase 4 when they convert to channel 34. And then WCVB will also have the ability to have this as an auxiliary from phase 4 to phase 8 when they lose their ability to go into their existing auxiliary. So one of the things I developed is the way to come up with these power budgets. And that again sounds pretty simple, just add up the powers. But when you have a lot of different channels with different ERPs, then you have to kind of conglomerate the each channel's contribution to the whole system. So you'll see these kind of power budgets as we go along. But basically, I did the prediction with all the antenna information of how much transmitter power it'll take for a given ERP. So that's just kind of showing you under the hood here how we came up with the numbers through a spreadsheet behind this that takes into account the transmission line size and the antenna gain on a given channel. So there's a bunch of tables, and what I want to be able to do is pretty quickly be able to change the transmission line size and see what happens for a given station with a different design. So that was the beginning of our market change. The second step is now shown on this chart. So we still have the side mount on the left, but on the right-hand side is what we're planning to do to the candelabra over at our Needham site. And early on, we've sort of realized that this tower at the Cabot Street site has particular limitations, several significant limitations, which are the guy wires are relatively short-spaced, which limits the load capacity in general. It's also got a very narrow candelabra, so it's one of the earlier candelabras that was built. It has 30-foot spacing or 35-foot spacing. Somebody, I think, corrected me before. So that spacing introduces pattern distortions for stations that are on the candelabra. So we made a decision, and the tower is basically at its load capacity now. So we made a decision early on, well, let's talk to the broadcasters about putting up a single antenna in the middle of that tower and taking off the other equipment that are on the arms. So thereby essentially making the candelabra back into a single stick. And that's what we're planning to do. One thing that came along that we didn't predict early on was Emmerich and his group were very successful in the auction and picked up a low VHF channel. Low VHF antennas are not typically very small, so we needed to find a location to put this VHF antenna. And so we've worked out a pretty cool plan where they're on top of this antenna that we planned at the candelabra site. So, so this is the stack that we're planning to put at the Needham Tower, where we have a channel 5 3-bay circularly polarized. That the VHF antennas are fully circularly polarized above a 14-bay UHF antenna. So some of the things that went on in that whole design process were WFXT has a directional pattern now that's pretty significantly directionalized to reduce signal. At the time, it was to reduce signal back towards New York. They had a co-channel in New York. They yeah. Okay, on the border there, right? And then Hartford and it turned out. Well, no, I'm jumping ahead, but they had co-channel interference issues that restricted their pattern on their digital channel as they're implemented now. So we knew we had to deal with that directionality. We were hoping, and our early investigations led us to believe that they would probably be successful in the auction and at maximizing after the auction rather. And so they had to file initially on their replication. So they filed to replicate with this directional pattern. And then in the meantime, we worked with their consultant to get as close to an omnidirectional pattern as possible. And we've really, Merrill Weiss worked with WFXT and really did a great job of trying to get the pattern for WFXT maximized to where it's very, very nearly omnidirectional. By doing that, he provided the ability for the other stations in the market to get an omnidirectional pattern while WFXT remained, quote, directional, but only slightly. So this is the pattern for WFXT, and it looks a little rippled up, right? Well, we don't like ripple. But in this case, we like ripple because within those ripples and in this 240 degree to 270 area, that's where Hartford is. And then on the 30 degree area, that's where Portland, Maine is. So by carefully rotating the pattern and slightly squeeze here and push out there, that's actually a directional pattern. So, so we really did a good job of fitting this directional pattern, which then the other stations can apply as omnidirectionals. So that's what we did, and it's kind of a unique solution to just take the standard antenna, relatively standard, a little bit of tailoring, and get directional for one and omni for everybody else. So this is the vertical component. Basically, you know, they're pretty close to laying on top of each other, which is what you want. The horizontal elevation pattern, rather. Again, we're planning a 14 bay antenna, so we have pretty good gain. So we could get all the stations in at high power, which is what we showed here. So this is the stations using this antenna as an interim main. So what we needed to do is we needed to get WFXT converted in phase 4, and we needed to get WBZ and WCVB converted in phase 4. But we needed WSBK and WGBX to weather on their existing channels through to phase 8. So that's what this chart shows. Shows new channels for 3 stations and old channels for 2. So this is sort of the plan for the operation from phase 4 until phase 8. So basically, if you're following the bouncing ball here, we're going to build the side mount, which we already did. We're going to then put one station in there. Then we're going to go across the street, tear that all down, build that, and have that ready by phase 4. So then we can move everybody, and they're going to have to build transmitters across the street to be ready for phase 4. And that's what this chart is. This is phase 4. They all flip over. They come on the air, either on their new channel or their old channel. And so that's what this does. So that's the construction we have to do between now and March of 2019. And then what happens is stations all convert to their new channel. So this is all the new channels on that system. Meanwhile, they all maximize, so the power levels went back up. So we now have 4 at very nearly a megawatt, and 1 at a little lower power, but you can see, it's running very significant power over there. So this antenna becomes the auxiliary antenna for the 4 stations that are now on Needham Heights. This is their auxiliary long term, and WFXT remains as their main. And then what we did, so we've actually discussed with the stations 2 alternatives for combiners. And this is the first one, which is what we call the single chain, where each station has 1 input and there are 2 outputs. And we fix remember I said the phase can be adjusted by station. Well, with this single chain, you set it, and then the other stations mathematically get what they get out of it. It can only be set on 1 channel. I'll just show you the other alternative is this combiner, where now you can independently change the phase with 2 chains of combiners. So we have a decision point to make soon, whether we go with this or the single chain, and obviously there's a cost differential as well as size, so it's a little bit bigger. It's quite a bit bigger. Okay. So now we've come to our last part. So now we've built 2 antennas so far, and now we're going to work on our 3rd antenna. So we realized now we've got this interim operation and an auxiliary operation, but what we really want to do is refurbish the existing operations for the 4 stations, and we've decided to put them into a new antenna on the top of Needham Heights. And we decided to do that primarily because the stations felt there was this turning point for having this future-proof system. And we were able to leverage the existing equipment that's there, meaning the transmission lines. So because that system had two 8-inch transmission lines already there that we could reuse, we're saving a very large chunk of money that we probably would not get reimbursed for. So we knew if we went to the FCC and said, hey, we're building 3 antennas, isn't this a great idea? They would kind of go, well, I don't think that's such a great idea. Why do we need 3 antennas? So we said, well, we're going to build 3, but we're going to reuse transmission line from 1. So it's really not that bad. And we were successful at running that negotiation because they did pretty quickly understand that if 5 stations went at it individually, that would be a heck of a lot more money than these people all combining together and pooling resources. So we did quite a bit of petitioning to make that happen, and we're successful at convincing them that this is the way to go. And it is the way to go because it does save significant money over what an individual station would have to do if there were 5 of them doing this process. Okay, so what's the antenna here? It's after all of that antenna talk, this is just a plain old 14-bay Omni antenna. And, looks like this. It's 55 feet tall. It's again the whole antenna is designed to have 2 equal phase signals throughout the whole antenna, and this system, since as I said we have the 2 existing 8-inch lines, we could reuse those lines and get the 2 feed lines, and then here it made sense right off the bat to go to dual chain systems, and this is the power budget. Again, all these are maximized, and we kind of quickly realized that we don't really have much control over what these stations decide they want to do, because we just told them they could get any amount of H and any amount of V. Well, obviously, if 2 of the stations decide they're going to go full CP, they use up half of the tower, the system capacity. We have a problem. So we've talked about this 30% V-pole limit as a good number to try to calculate what the capacity of the antenna is. So that's what we've used. And you can see we're trying to be relatively conservative on the how much we're going to put in the antenna, but at the same time not over designing, not choosing those bigger lines just for the sake of choosing them. So.
I have one quick question. How do you do maintenance on the individual transmitters with that combining system? Is there a way to connect to a dummy load? I don't know, going through that.
Yeah, so that's I think so that's a good question. So that is a limitation for this combining system. Is so the question was how do you test individual transmitters? The fact is, you don't test an individual transmitter into a load through a mass filter in this arrangement. You do need to test as a group, and if you're going to do some well, first of all, there's 2 things to that. One is you have a whole backup system at an offsite, so that's sort of the key to oh my God, we have a problem in the transmitter, what are we going to do? Well, we're just going to turn the transmitter on over there, which gives us the same ERP or the same coverage and can operate over there without really getting the general manager and in a tizzy. So that's something that we've never had before, particularly here in this market, as many of you know. So that's sort of a fundamental, right, to that question is it took away the 2 a.m. fire drill. Yeah. The second thing is that you can have a load separate from the mass filter. So you could test a transmitter. We haven't really set up a system for that, but we've kind of been thinking about what a test system might look like for the transmitter. So the definition of a transmitter has to somewhat change from what historically it was, because the definition of a transmitter now is the output of the mass filter. So the output of the mass filter is the combined output in this case. We're going back to more of a transmitter definition is the box, that outputs RF, but it's before the mass filter. So that could be separately tested. And I think that would be the method you would use if you were going to do, if you had some tube failure or, yeah. And so we've also been working with the transmitter manufacturers to kind of figure out the testing method. It's not completely new ground. They've done this sort of system several places, but there is some new ground with it. So it's a good question, and that's something I have to work with the transmitter people and with the combiner designers as well to optimize that. So this is the plan for a dual chain system. Again, because we had adjacent channels, we really needed to use this approach with the constant impedance modules, and it tends to work out well. So that's the end of what I have. Just we're working very, very hard to meet the project timelines, and I think our plan really gives us the ability to do that without a lot of problems. And we as American Tower are really interested in investing in the Boston market. It gets a lot of visibility. So the CEO of our corporation brings whoever comes to his office, he usually brings them out to the Candelabra or out to Needham Heights. So from a corporate visibility standpoint, there's nothing like the towers, 6 miles from the home office to get attention. Like I said, the key is the future proofing and having these multi-site solutions and trying to stay ahead of the industry, which is something we really pride ourselves on. Any other questions?
Yeah. How does the complexity of the Boston market Repack compare to other markets around the country?
Yeah. So I didn't put up the slide with all the other markets we're working on, but we've been doing similar projects in how many sites we got now? I can't even keep
So we're in 9 markets, about 15 new antenna systems we're putting up. But Boston is probably, technology-wise, the most advanced, where we have we have almost mirror systems on both sites. So setting the Boston TV guys up for 3.0, especially if people are talking about wholesaling spectrum, that business model where you need SLAs. So if you sell spectrum to Google, Microsoft, whoever, they're all going to want a service level agreement. You guys have almost perfect really good coverage in both. Very high-end systems on both towers. So you've got good physical diversity.
Yeah, so that was an important thing that did happen in Boston. It didn't happen in a lot of our markets, but there's only a few other markets. I would say Dallas was probably a market where there were more repacks, and we have a lot more resources there, but there was a lot of repacks. And then where we thought we were going to have huge problems was LA, and it turned out that, you know, LA essentially got decimated from broadcast. I mean, more than half of the stations sold in the auction.
So there's a whole big frenzy going on in LA of sharer and sharees. So these guys all sold. They got their millions. They now want to use someone else's system to broadcast to their existing. So they don't want to leave. They just want the.
Yeah, it's been really interesting to watch who these stations have teamed up with on the share-sharee relationships, and there was a kind of a real horse trading going on out there in LA, and you know, being LA, they are a little independent to begin with, and it's been quite interesting to watch.
We've been, you know, doing similar presentations in Houston, in Tampa, Orlando, Norfolk, Virginia, Oklahoma City, Dallas, Houston. We mentioned those. LA, more single frequency, big systems. So
Yeah,
Detroit, yeah.
What else is going to be shared besides everything that's on the tower? Buildings, HVAC, backup power? And
Yeah.
what is the cost of this conversion?
So
Not counting transmitters.
yeah. Well, let's start with the first question. The common. So part of the concept was to make common as much of the system as possible, particularly like room space, cooling systems, generators, if we can work that. So our efforts have been to put as much of that into common area as possible. That model's already been in place here in Boston for quite some time at the WBZ site. So it wasn't hard to conceptualize that here. Everybody already was working in that, where they were all the transmitters were just laid out in a row. We're actually introducing that in other markets where they, you know, that whole thing is completely foreign to them. You know, they all want their doors and, you know, locks, and that guy can never come anywhere near my transmitter. So that's taken some work in other locations. So that was just kind of the key, right, to the design is let's, you know, but they all complain about how their air conditioning goes out, you know, and boy, wouldn't it be nice if we could get one guy to do the air conditioning, you know. So that's what we've listened to and implemented. Cost, I'll refer to my sales colleague because that's his job, is to keep track of the costs.
These are all pretty. These are multi-million-dollar systems we're putting in place. So if you want to know specific costs, you can go to the FCC website and look at the 399 filings. That'll tell you what people filed for, both on the transmitter side as well as the antenna side. But if you look at those antennas, those 55-foot, 20,000-pound broadband antenna systems, they're anywhere from $600,000 to $750,000. So for an antenna, transmission line, if it's 8-inch, it's about $300 a foot, and you're talking about thousands of feet times 2. Combining systems, 75,000, 100,000 a module, so per station. So those are just some high-level numbers to you can start to calculate what you're talking about.
What's the cost of labor?
and then that's the other thing is crews.
Yeah.
And that's really one of the areas that Jim and I are most nervous about, is we're pushing our broadcasters to kind of finalize their technical decisions so that we can then put a scope together, a final scope, and get crews lined up. And the crews aren't busy right now, but they will be. And as we get to, 6 months in, 8 months in, it's just going to get worse.
So past the initial capital in the deployment, what is there an additional cost of being a tenant for the redundant facilities capability of this?
Yeah, so our model is pretty straightforward. we try to maximize the economics as much as possible with the FCC. And the FCC ruling is like for like. So if you have an H-pole antenna, you get an H-pole reimbursement. And that's what we provided to our broadcast customers. If it was an E-pole, it costs more. So that cost it basically gets borne by the broadcaster, that incremental cost. And it can either be a increase in tower rental, or it can be a one-time capital increase. So that's the model.
Neil, why don't you come up and,
Oh, okay.
yeah.
So you said it would be possible to work on the Needham Heights main transmitter or the top transmitter or top antenna while the auxiliary antenna was up there. How would that be done safely? Would you be using a gin pole to do that?
Yeah, so what I'm referring to is you could operate on the whole other site, which is a mile away. So there's really no safety issues. Very little RF coming from one to the other.
So the side antenna in the Needham Heights tower would not be on what was being worked on above?
Well, you could operate from that antenna down lower. So the way UHF antennas work, they actually have very little energy straight up and straight down. So RFR, once you're 50 feet away from that antenna above it or below it, you're typically okay to work. You obviously can't pass in front of it. So there's like 100-foot dead zone when you're operating on a given antenna. Not literally. Hopefully not literally. Yeah. But having the whole off-site system solves that problem. Many of our sites, we don't have that luxury.
But I mean, it's a really good point, because in Detroit, we have a tower in Detroit, and we're putting a side mount down far enough on the tower so that we can operate down there while they change all their antennas on top safely. Because we're not big believers in this, in really wearing the RF suits. So it's up to the crew at the end of the day, but we want to have the crew to have the option of operating safely, if at all possible.
How do they get past it? Do they go up in helicopters or?
No. So if the way it would operate is if you have that side mount antenna operating, they'd have to power down as the crews climb past, and then it powers back up. And then what we would do is the guys on the top, if there was work going on in the top, they would do all the top mount work. We would power up the side mount, and they'd operate off that side mount during that interim period.
Yeah, we helicopter lifts are obviously possible, but we're trying wherever possible not to do helicopter lifts, because not necessarily because of the amount they cost, which is quite a bit, but the planning and it really limits you to flexibility. I mean, you basically, when you have that helicopter scheduled, you better lift that antenna. Everything better be ready, and a lot of things have to align. So scheduling wise, it's a really difficult, along with a lot of other difficult things to do with a helicopter at a site. But we're trying. Most everything is with a gin pole that's rigged on the tower, and things will be lifted off the ground from there. So
the two antennas on John Hancock in Chicago, we're working on a project there as well. Jim's figured out a way to break the antennas down small enough, and these are big 50-plus foot antennas, to go into the elevator and go up and take it up that way. Because what do they call Chicago? The Windy City. Yeah. Do you think wind and helicopters work too well together?
yeah, they actually did at the Sears Tower. They did a helicopter lift, and they had to wait about 3 weeks to get the exact window, to do that helicopter lift. It was.
Yeah, we probably will do a helicopter lift in Dallas, because we've got a stack there, and so that'll probably happen. I don't think we're gonna attempt it here.
Jim, did you get stuck with any Channel 14s anywhere?
No,
Just wondering.
don't anybody move. We had no 14s that we know of. I have to quantify that, though. No, we did not. So one of our customers
Has several.
in Orlando has
And in
one.
San Francisco.
But none of the broadbands have
Channel
any 14. Yeah. So I guess I have to say we did have two,
Yeah, San
two
Francisco
resulted in
and,
14
and Orlando.
but none in the broadbands.
In one of your early slides, you mentioned something like, was it 4 or 6 million acres of land to be able to build towers on as one of the parts of your portfolio?
Yeah, so what we're doing is we're actually buying the land below our towers so that we don't have to pay high rent or have a dependency. So,
Yeah.
so if you look at the Needham Heights Tower, which is the proper name, we do have 44. We have, I think it's 44 acres of land underneath that tower. I think it's 44 in Needham Heights. So, I don't know what, as you drive down the driveway there's $1 million+ house right there.
So if any of you live in Needham, you can thank us for lowering your.
Yeah, we pay a lot of property tax in Needham
The other
Heights.
question was, were you acquiring land in anticipation of the additional towers needed for 5G deployments?
Yeah, we actually, we are securing land on the wireless side. And we actually work with our customers and we get search rings from them. And we try to figure out where it makes sense to own land, and we're proactive. And then we go work with them on building a site, get a commitment, and we go build the site. So, but that's really on the wireless side as opposed to the broadcast side.
We just don't see very many broadcast towers being built, just the difficulty of.
Yeah, my curiosity was for the wireless, just
Yeah.
because what's coming
Yes.
up.
Yep, yeah, was somebody.
Yeah, Jim, can you talk about Cabot Street for a minute, or is that Needham Heights, or whatever the correct name is, the non-BZ tower? Candelabra on it.
Needham.
There we go. Well, we're in Needham here, huh?
Yeah, they're all Needham. Pick a Needham.
Are you planning a common facility there? From working from Channel 56 years ago, you got the Channel 25, you got the Channel 56, you got these little buildings, but you're gonna put this combiner. What's the plan? Where do the transmitters go? Are you gonna build a common facility? Is that the situation?
Yeah, so, so, as you all have acknowledged, one of those stations is not gonna no longer be in operation in a couple months. So that's one of the facts. The second is Channel 25 would stay basically where they are. And then, so the area that was SBK primarily, as you know, that area will become common area. Fortunately, transmitters are a little smaller than they used to be. So we can pretty easily fit the transmitters into that area along with the combiner. The combiner will be in the garage, basically.
So it's basically going in the 38 old building.
Yeah, so 38 space, plus we're also taking over some of the space behind LVI or to the north of LVI for the VHF. So, Mike.
So I have a question again about the 140 Cabot Street address. Regarding when you're actually doing the gym pole work in the tower, are you going to be closing off the parking lots of the hotel and working with the businesses that are right underneath the tower to restrict access to that area and stuff during the work?
Yeah, so that's obviously something we gotta work out. As you know, there's, I think we definitely would have to restrict access coming down the little loop there. Luckily, that's a little outside my pay grade.
Yeah, that's one of the long lead items at the Needham site. We did have to get a permit for a tent to have a party there, I hear.
Oh, that's right.
It took 9 months to get that permit. So there's a lot of lead time items that are going to get impacted. We're doing the zoning and permitting, and we'll abide by the local regulations and basically work with them to map that all out.
Yeah, I mean, well, you know, Mike, we did the last lift we did pretty much in the middle of the parking lot, so.
Yeah,
uh,
but
so
I know that when the tower was painted, they put yellow tape across, and everybody just walked under the yellow tape. So, you know, I just see that happening again when you're doing that kind of work too.
Yeah, I mean, that's, you know, one thing about American Tower is they're very, very focused on safety. You know, and we actually, we get crap from some of our customers about how, oh, I had to do this to jump through a hoop for your safety guy. And, well, yeah, that's because we want you to be safe, you know, and it pays off.
I mean, Jim Tinkler, our CEO, basically calls us a safety-first company. So he wants every employee to go home every night.
Yeah, so that's a sort of overarching, you know, not all companies do that, and for us it's very important, so, yeah.
Can you elaborate on the way you work with the climbing companies to manage their safety measures? Because there was a gym pole collapse recently down in Florida.
Yeah. Yeah, in fact, so, yeah, that did happen, really unfortunate, and a group we know very, very well, who's, by the way, Safety Rec, who is an American Tower approved vendor, or was. Unfortunately, they won't be now, because one of our safety requirements is you can't be under OSHA investigation, which they now will be. But they really had an unfortunate problem with the gin pole and a very, very similar situation. And it really goes to how sensitive this business is, you know, mistakes happen and they're very costly. So we have to really pay attention to those things. And so as far as our safety program, rigging plans have to be worked on by an engineer. So every project has an engineer that's assigned, a structural engineer, and he has to develop a rigging plan. So exactly how he's going to do the rigging. So it's actually generated by the structural engineer, not by the climbing crew. And most everybody does that anyways, but that in general is how the rigging gets done, is through a rigging plan that an engineer makes. And they must be executed. So no work will happen on a tower without a rigging plan from an engineer. So that's the primary way. And then, you know, we check, you know, do they have any OSHA issues, to, you know, all of their own safety plan. Every rigging company has their own safety plan as well. They have to have morning safety meetings, and then they have to have a evening debrief on that day's activities. So there's steps that are pretty rigorous.
And we've also hired broadcast construction managers for the Repack. So they'll actually be on site overseeing the work. And they have the authority to shut the site down if there's any safety-related issues or concerns.
Yeah, that's good. But, you know, make no bones about it, it's a very, very risky operation. Got to be done carefully.
I'd heard that some radio stations were being affected by this, and I can't imagine why, except that they're on the tower, unless there's more to it.
Yeah, we've had quite a bit of conversation about FM and as well as non-repack stations. So the FCC has set up this reimbursement program for stations that are repacked. They did not allow any money or compensation for stations that are not repacked or are FM on a tower. So we've been out now for 2 years saying to FM stations, if you're on a tower with a television station, you need to work with that station to understand what's going to happen in the repack, and then understand what your opportunities are for needing an auxiliary. You know, do you have an auxiliary? Is it off-site or is it on-site? Is it low enough? You know, you need to work that matrix because you're not going to get any compensation from the government to keep you on the air. And, you know, us as the tower owner and any other TV station who's a tower owner, they got to get this work done. There's a deadline. There's no, you know, the deadline's a hard deadline cut over, or you lose the ability to transmit. So the radio stations really have to bear the brunt of some of this repack happening. Does that answer your question?
Well, yeah, but in what way? I mean, if they have, are they sharing lines with the TV stations up to the antennas, or are they?
Well, no, not very often. I'm not aware of anybody sharing lines, but you know, in general, they share the tower, right? So when the tower workers are on the tower, for instance, at our Tampa site, we have 10 radio stations that are on an antenna on the candelabra, which is on an opposite arm of the candelabra where we're going to build one of these new broadband antennas. So those 10 stations are going to be affected, which, by the way, there's also two other antennas being changed. So you got two antennas being changed and a whole new reconfiguration of the top. Well, those 10 stations got to figure out what they're going to do during that period. They may be required to be off air many days in a row, not just hours. What? Yeah. So because of RF safety, yeah, it all primarily relates to this RF safety issue. When they're rigging in the proximity of the antenna, they won't be able to operate. All right.
All right.
Thank you.
So I want to thank Jim and Neil for a great presentation on the state of the market. And there is one more announcement to make. WCVB has a new director of engineering, Mr. Greg Turner, who was in the house. Greg, stand up, please. Greg comes to us from KCRA in Sacramento, and before that he was at WDSU in New Orleans, where he had the responsibility of bringing the station through Hurricane Katrina, and survived an amazing process there, and some antenna issues along the way. So anyway, thank you for coming tonight. I think Marty has one more word. Thank you.
Thank you, Dave. I hope you'll all be able to make it to Woburn on December 6th. Should be an interesting program. I want to take this opportunity also to thank Foxborough Cable Access for loaning us the HD cameras, and to Paul Beck for running them. And Foxborough has also offered to edit it for us. So a big hand for them. Thank you very much, and hope to see you December 6th. Thank you.